Um, Maybe take a seat again, please. Next speaker is Jan Marsch from OSM Buildings. Have a good start.
Thank you very much. So, trying to open the presentation. Okay. No. Okay. Good. So, yeah, welcome to my talk. This is not primarily about OSM Buildings, but yeah, something we are trying here as an experiment. My name is Jan Marsch. I'm the creator of OSM Buildings, so that's basically a 3D viewer for OSM data, specialized for building data. Yeah, most likely you know the project already, but what I'm going to show today is more about 3D printing. So for the most recent version of OSM Buildings, I implemented a 3D printing function, which is not really the print itself. It's more or less an interface to a print service. So there's no live demo here, but there's a live demo here at the end of the room. So you can, everything I show you or I explain here, you can see yourself at the end of the room, and you can also try out all the things. So this is basically a print selection. If you go to osmbuildings.org, you can open the menu and you can have the square somewhere here on the screen. This one, you can open that, you can position it, and you can scale it. And all the data which is selected that way can then be transformed into something printable. The printable data is so-called STL format. So let's see what happens. And for that, I'm pulling from OpenStreetMap building footprints, for example. Then usually I have building height information. It could be levels, it could be meters. And out of that, I can create a 3D model. That itself is not printable, so it needs some preparation, some conversion. So I create triangles out of it and then have a conversion process to make a so-called STL file out of that. That's more or less the thing I'm doing. And once I have that file, I'm sending that to the 3D button service. That's nice people from Free Your Mind at the end of the room. They created an API which can consume STL files. I can send all that in the background, and when it works, we get something like this. So this is the already prepared or print-ready file. You can see that on their site. You can play with it, you can repair it. That's the symbol here. So if it needs some kind of repair, and usually nobody of us has an idea how to repair a 3D printable object. Usually there are walls missing, or objects are opened, or walls are too thin. That's all something in very, very most cases, the repair method can fix. You also have the option to scale the model. So I mean, you can print it in meters if you like that, and if you can pay it. Usually, of course, you go for a few centimeters. You can choose materials, and yeah, I wasn't really aware before what kind of, for example, metals are printable, and this is really crazy. So you can have it printed in gold, if you can afford it, or you can have bronzy or silver, or even just steel, stuff like this. So that's all your choices. There are providers down below. So this is the service itself, or the website itself you see here. That's not really the print service. It's more like a provider or a platform that offers you to use other printing services. These are listed below. I mean, try it out later. So you can choose a provider you like, or which is nearby you, and you can order it. Or even better, you see the price before, and then you can order it if you like. So, and yeah, the nice people also brought a 3D printer, so we can play the whole process on our own, on site. And yeah, so that's our very early tests. What we did, it's the Berliner Dome on the right side and Museumsinsel on the left side. Meanwhile, the quality got a lot better. But what we are offering today is not really not huge models, so we wanted to keep this very fast. We might print something which is maybe the size of a stamp, 3 by 3 centimeters. So don't expect a full, nice architectural model, but maybe something you can recognize and maybe find your street, find your house, select that on the map, and you can really get it printed today, and you can take it home. Yeah, get yours today. Yeah, and the thing I'm going to make out of this is also to publish this STL creation service. So right now this is a bit hidden in the background, and I think this can be useful for any kind of manufacturing processes. So I will publish the STL service. Ideally you just send a bounding box or maybe an OSM object ID, and you get back STL data, which you can have processed anywhere, any kind. Yeah, that's about it. I guess there are probably more questions than things I can explain right now. You find something about the STL format and all our websites, and yeah, I'm here for questions.
Yeah,
Thank
thanks. So again, the 3D printing happens over there. So did it already started, or?
Yeah, we are already printing. We have a few examples already prepared, and yeah, go there.
Yeah, so just grab yours. Any question? Really, nothing.
Oh, okay.
Wow.
I mean, approach us.
Yeah, self-explaining topic. Okay.
Good.
Thanks, Jan. Our next speaker? Yeah.
So, hello and welcome to my presentation about 3D rapid mapping on mobile devices. My name is Clemens. I'm a master student of the University of Applied Sciences in Salzburg for computer science, and I'm also part working for the geoinformatics department at the University of Salzburg. This summer, the Department of Geoinformatics announced a project and chose 4 students out of the applications. One of them was me, and we were supervised by Dr. Bernd Resch and Professor Blaschke. The intention of this project was that there are multiple solutions which perform structure for motion or hard computational algorithms on PCs or on servers. And we think that it's possible also to do this on standard smartphones in real time. The overall application would be that we have an application to navigate through a building by simply taking pictures of a room. Okay, so at the start we did a little research phase, and I just want to point out 2 publications. The first one is a continuation of a publication of 2011 and is continued 2014. They have a similar project than us. They take pictures of a room, then send them to a server, to an external server. This server extracts the features of the images and compares them with features in a database on the server. At the end, the smartphone pulls the request to get the location where it stands. And so we think this could be also totally done on the smartphone itself. The other publication I want to mention is announced in 2015. There the scientists just place an objective on the table, move the camera around, and instantly get a 3D model out of from the object. This is completely done on the smartphone, and I want to mention that they use the resolution for the images 320 times 240, which is extremely small. So at the beginning of the of our project, we defined what could be our workflow. First, we take some images, then we process structure for motion. Shortly, a description of structure for motion. This is how you can get a 3D model out of 2D images, which is coupled with the local motion. Then we have to do point cloud processing, and we also do the visualization of the point cloud, but this is just a byproduct as we want to get the significant points out of it and don't want to visualize the rooms. At the end, because the project is still in progress, we would like to implement a fingerprinting algorithm and then have indoo positioning. So at the start we have an evaluation phase and looked at different libraries and softwares to find the best solution for us. One of our major criteria was that they have to be open source, that we can reprogram parts of it and can hands on the code. And half of them were open source, and one of them is in brackets, the libviso2, because they stated they are open source, but they never send us any code, so in our definition they are not open source. Then we defined if it's a library or software. A library would be preferable, of course, but when we have an open source software, we could also extract the models which perform structure for motion. And at the end, we wanted to know what's the organization behind those projects. Then we take a closer look to certain candidates and defined other criteria like the dependencies, input-output, documentation, API, features, and so on. And at the end, we decided to take OpenMVG. OpenMVG is written in C++. It is a collection of tiny open source libraries, so we don't have to use all of them, and this is very helpful because we want to keep the data storage as minimized as possible. It has integrated an incremental and a global structure for motion pipeline, and the author of OpenMVG was very enthusiastic and wanted to help us, and his name is Pierre Moulin. But we had some major challenges to face, namely OpenMVG was just built for Linux and Windows currently, and we would like to use it on an Android smartphone. Therefore, we had to build OpenMVG for Android, and as another challenge is that they have a lot of C++ standard functions. They are not fully compatible with the Android operating system. And the last challenge would be that it also has a lot of dependencies, like Eigen, the series solver, and other, and this could always be a spot which could be a problem in the end. But we succeeded in making OpenMVG usable for Android and solved the stated challenges and successfully performed parts of the structure for motion pipeline. Then, meanwhile, we tested also the OpenMVG library to find the best solutions to use it. I would like, this is a short GIF. These were the pictures we have taken for the experiment. It's a kind of a messy table with, for example, the bottle on it, and we tried to visualize it in a point cloud. Therefore, we use the global structure for motion pipeline, and I would like to shortly describe it to you. We take some images, extract the features out of the images, then then match the features of the images, and estimate the camera poses from which angle the pictures were taken. At the end, we perform the SIFT algorithm and create the point cloud. And at the end, we do bundle adjustment to reduce the residual errors. And as you can see, at the end, we get a point cloud. So these were our first results from our experiments. There were the setting normal. You can see the bottle and the monitor as well as the desk. And when we set the setting to high, the floor gets really high density, and as well as the cupboard besides. And it has another setting called ultra, and there the density of the point cloud is extremely high. But it also takes a long time. This is illustrated in the next graphs I will to show you, and to find this we have to find the best parameters for the resolution and the number of images to keep the computation time as low as possible. Therefore we use the windowing method, as we take a picture of a room and then just move 30% up, and then we have an overlap of 60% to the next image. This was our output of the first experience when we changed the number of images and as well as the settings. There you can see that the y-axis at the top is in minutes, and the bottom graphs are in number of points, the y-axis. And the x-axis is always the number of images. You can see that it's is an increasing slope like an exponential function in the minutes, and it's very linear when you get the number of points. We think that it's in 10 minutes you can see that the slope of the high setting is as well very low, and you get already a large number of points, about 2,000 points. Therefore, we used it in the next experiments with more resolutions, and we wanted to see if we get the same result in different sceneries. As you can see in the image in the graph right at the top, there we use the resolution 800 times 600, and sometimes we get almost 0 points when we use the low setting, but when we take more images, it's always more computation time. Therefore, we wanted to emphasize the higher resolution as the computation time is still very low, and we get a lot of points, and the variation is also very high. So this has currently been done. We want to combine the app from structure for motion and the visualization together, because we visualize it as well in an app. We would like to do a point cloud merging if it's necessary, and have to reduce the number of points if needed to keep the data storage low. And in the end, we want to implement the fingerprinting algorithm to perform indoor positioning. So in my last slide, we have some open questions, and I would like to hear maybe some experiences or solutions from you. The first one would be, what would be the best point cloud reduction algorithm? Do you have any experience with fingerprinting algorithm for indoor navigation? Is probably served the better solution as SIFT in the mobile device world? And how we can increase the algorithm performance? Otherwise, we can talk as well in the break. Thank you for your attention.
Yeah, thanks. I think for the first point, maybe we would have someone from the autonomous car data collection team here. I don't know, anyone here? No. I think the second point is, I mean, we have an indoor topic afterwards. Maybe it would also smart to connect then with these guys. Bernd from indoo.rs is also, I think, there. Where is he? Ah, here. Okay. Maybe you have some suggestions already? Okay. Okay. Yeah, I think it's also great. Well, anyone else has some opinion? Ah, yeah, there was a question. Sorry.
That wasn't a question, it was a comment to your questions there. So I was involved in research about indoor localization in different institutions in Germany and in other countries. And we investigated if we combine different algorithms for indoor navigation, then we could achieve, increase the probability of recognition dramatically. And then we investigated how many of these technologies we should combine. And the surprising result was that if we combine two different technologies that are kind of have the principles, the physical principles behind are kind of orthogonal to each other, so not two similar methods, but two completely different ones, then you significantly increase the recognition rate of where you are in the upper 90%. So let's say something spatial like Wi-Fi fingerprinting. If you combine that with being recognized at certain points, like seeing a visual marker or passing a RFID gate or so, then these are two completely different principles, and combining these dramatically increases your recognition rate.
Was it helpful?
Yeah, of course, yeah. Maybe
Okay.
we can talk in a break as well.
Okay. Any other question, comment, whatever? Yeah, then thanks again for the talk. And as said, the next speaker, Bernd from indoo.rs.
Yeah, hi everyone. My name is Bernd. I'm co-founder and CEO of indoo.rs. What we do is we provide positioning and navigational services for Inside. But what I want to talk today about is actually what trends we see or we have seen within the last year and what has been going around in the industry. Trends from a marketing or market perspective as well as from a technology perspective. First, short about us. Well, we're 26 people in Austria, 2 in the US. We completely focus on the part of indoor positioning and navigation for mobile applications. So we really concentrate on smartphones like Android and iOS. Maybe some key updates on the market players. I've been in talk with 2 other CEOs frequently from our competition or our competitors, and what we've seen is that right now worldwide there are around 77, or as Gartner says 100 companies that purely focus on the indoor positioning and navigational market. Actually 20 of them got VC money, 5 of them are big boys like Google or Apple who are really investing heavily in that space. 16-20 companies went out of business last year and 10 new emerged. So you see it is still a hot topic, it's still a hot industry where a lot of people spend their time and their money in. Market trends. For us it looks like that, and this is out of talks with other companies, that the iBeacon solutions are now kind of part of the game. So this, you walk by a shop, you go into a shop and suddenly a coupon pops up and so on and so on. This has nothing to do actually so much with the positioning or with the navigational part, but it kind of works as a door opener for a lot of companies. So you first start with place some beacons for, I don't know, someone gets in and gets a coupon, and then you extend that, you augment that later on with indoor positioning and navigation. The market still has to be evangelized. It's still a rough market, I would say. A lot of people have tested stuff or did work with companies who overpromised. There are a lot of burned fields, I would say, where we then have to go to and renegotiate with them again and talk to them. Okay, you know what? Sub 1 meter level of accuracy only based on Wi-Fi fingerprinting. This does not work. But if you combine it with this and that, and as already it was told in here, it's not only about one technology, it's about the combination of a lot of technologies, then you can get to a certain amount of level where it's accurate. And some of the technology companies switched to solution companies, which we saw. So one of our biggest competitors actually, they switched to a solution company because of short-term revenue streams. Well, this is always one of my slides where I say, okay, these are the areas of application where indoor positioning really works in, and now I'm going to go into details around which industries we've seen that invest and that work in that field right now, or where projects and solutions are deployed. I only concentrate there on Europe and the Northern American market because I've got only an overview of that market. The Asian market, I'm not an expert on that, so please don't shoot me. And also, this is not like an exclusive list, it's only the projects we are aware of or actually our competitors are working on. So let's first look into travel. Travel works. We've seen KLM, San Francisco, Schiphol, American Airlines, even, what was it? I think the Mumbai airport and so on, who really invest in the positioning and navigational market. So this industry does work with indoor positioning and navigation services and will continue to work on it. So good thing if you work in that industry. Retail, retail as well. May it be IC, so the Hamburger shopping mall, may it be Macy's, Carrefour, Immofinanz, and so on. Those guys also do projects, do invest in that space. May it be the shopping mall positioning part, may it be the in-store positioning part. Very surprising for me. A lot of we got now more clients in the in-store positioning market than in the retail or in the shopping mall market. So you search for a product and you get yourself routed there and so on. I always thought that these guys are going to be the last ones because it's retail, it's, you know, they optimize on where to put products and not that someone can search for them, but actually they're now investing it heavily. Next one is social e-commerce. So social e-commerce, well, I've only seen actually one project so far that's done something with it. So social e-commerce is if you walk into a store and then later on when you go home, the app recognized that you have been there and sends you a special newsletter, for instance. So let's say I walk into a department store, I've been for 5 minutes at the male shoe section, then did not buy something, walked home, then I get a coupon or a newsletter specialized only for me. In principle, this sounds really great, omni-channel as they call it. Well, as we found out, or what we have seen with our clients is, first of all, connecting the CRM data with customer behavior is not something they are familiar with, and it's not done in an easy way. And the other thing is, there are simply no responsible persons for that in that companies. So, for instance, we do generate reports on how people walk in specific stores, but inside of those retail companies, then there is no one who can take that data, look at it and say, looks nice, yeah, maybe we should change it that way. No, what happens now is they get the printed report, they look at it and say, nice, thanks. So, you know, these companies have to kind of catch up with that. Enterprise market is a market purely for, I would say, in enterprise store, application stores, so some apps that are not publicly available. And there we have seen actually a lot happening. May it be meeting room navigation, may it be colleague finders, may it be security monitoring, may it be resource allocation of where someone is in a specific area. I could not put here actually logos on it because these companies tend to not want to have the logos on presentations, but I can tell you that huge pharmacy companies, huge, even in the food section, companies are investing heavily in that space because they can reduce the time of someone looking for a meeting room or people waiting there for someone to join them and so on. So this is really a space that's picking up also in 2015. Manufacturing is, I've seen so far a lot of things happening. May it be Airbus, when you have these specific tools that if you take your tool to somewhere else, it automatically reconfigures, so you don't have to switch anything on that tool. Or may it be VW inside of their factories where they track all their stuff. Well, this has been a successful market in 2015 for indoor positioning and navigation. Public safety, we heard yesterday a little bit about the new NG 911 standardization, which means that the FCC in the US said, okay, for 911 calls, so 911, you know, the emergency number, if I call them, not only my GPS position will be transmitted, no, also my indoor position will be required to be transmitted from the mobile operators. However, we won't see that services live until 2020, so it's moving slowly forward. They are thinking about investing in stuff like they call urban beacons, which is a totally different service. And as this infrastructure is set up by the state as well as by private companies, it looks like this information won't be then accessible for us, but only for the telco operators. And if it will be or might be accessible for us, it might be really cost intensive. We already had talks with some of them who are setting up this infrastructure, by the way, which will be available in 2020, and so far it doesn't look like this will be a system we all can use, because they say, nah, we invest in it, so it's ours and it's only meant for our services. Entertainment, surprisingly, we have not seen a lot in the entertainment space. Yeah, we have seen iBeacon solutions, like, you know, you walk into a theme park or so on and then you get a coupon, but for positioning and navigation, not so much projects. Only I don't know why, to be honest. We do get inquiries about that quite a lot, but it seems that this industry is still a little bit behind because it works anyways. People go there anyways, so why invest in additional services? Entertainment. Well, and events, sorry, this is actually events. Event industry is investing it heavily. May it be the Mobile World Congress, where maybe some of you have been last year, who invested in an indoor positioning solution, will be there next year as well. May it be Art Basel, Messe Zurich and so on. So all of them actually see the demand of having an indoor map or having an indoor positioning service that they can rely on. So the event industry is picking up there. Museums, funny topic, just talked about with a colleague. And museums want that, museums need that actually, but they have A, no money, and B, are sometimes state-owned, so they are quite slow in the process of doing it. So we have not seen yet that much museums actually, because it's such an obvious case, you know, you're searching for that art and you just get yourself routed there. Yeah, in principle it is, but those museums work a little bit different. It's a whole different market and yeah, not a lot of money in it, so has not worked out that well. And the last one is mobile games. I only actually know about one mobile game that uses indoor positioning navigation, which is KLM Jets. It's a game that if you're on time at your gate, you get extra you get extra coins actually in the game, which is a kind of nice thing actually, because that's how they drive the people to the gates, to be at the gates more easily. But it's the only thing I've seen. Maybe there are others. I'm happy to talk about them. So for 2015, we've seen travel, retail, enterprise, manufacturing, and events actually to work in that field, to use indoor positioning and navigational services. Hospitals picking up as well, but yeah, quite easy task. So this was it actually from the market perspective. I want to get briefly into a technology perspective as well, which technologies we saw emerging or which makes sense. So if you've seen my slides last year, you might be quite familiar with this one. So the good thing is indoor positioning is working. There are technologies out there, maybe camera, maybe beacons, maybe Wi-Fi, maybe PDR, sensors, geomagnetic, and so on, that deliver you a solution that is 2 to 3 meter accuracy at 99%, some even lower than 1 meter of accuracy all the times. So that's a good thing. The technology is out there and it's working. What is the bad thing actually is the manual mapping time. So if you think about, you can set up one building in, let's say, a day, which is normally not a day, it's more normally 10 days. And you then think about 1,000 buildings. Well, this gets then quite expensive to set it up and to do so. And for this, we actually, so the current process is not infinitely scalable. It is what it is. The good thing is there are now technologies emerging and technologies out there called SLAM. We know them, some of you might be quite into them, but also for manual fingerprinting and for generating fingerprint data based on SLAM. So what does this mean? Short disclaimer, it's one of our technologies. So what you take is, what you take is you take the, you see that? No. You take path on how people walk through a building. So based on how they walk through a building, just having their phone in their pockets, you take this path. You know how they walked. And then based out of that path, you can build the fingerprint data. So nowadays, the manual fingerprinting works like this. You go into a building and you step and you make a manual fingerprint. Then you walk 2 meters further and you make a manual fingerprinting. But what the SLAM engine actually does is it does that automatically. You just walk through the building and the fingerprint data is generated automatically. And this speeds up the process like by a factor of 10 easily. I want to show you from one of our clients actually where we used our SLAM engine. The dots represent on how good the quality of the fingerprint data is. So it's not 100% perfect yet. But if you look on the left side, this was 2 people for 2 days mapping the whole building. It's a huge electronic store in Germany. And you see, yeah, well, by the way, blue is good and red is not good. So that, you see that the data looks quite nice on the left side. On the right side, it's actually SLAM, and it only took us 1 hour, one guy walking through that building. So you see a dramatically reducing of the amount of time people have to spend setting up the indoor positioning or the indoor positioning environment. I mean, it's still not perfect. You still have to have 1 hour, but it's way less than actually 4-person days. And this will be the future, and it's technology independent. So may it be beacons, may it be Wi-Fi, may it be I don't know what. This technology can crowd harvest all that data. And one step further, also kind of disclaimer, this will be released by us. We're talking about the SLAM crowd engine. So all of us walk through buildings with our phone in our pockets every day. And what we actually could do is we could create fingerprint data for all of us walking through buildings without having someone entering any manual input. So if you think about it, let's say you have an app that, I don't know, 10% have installed, and you let this app crowd slam the world. Well, within 1 or 2 weeks, you would have fingerprint data from all over the world without having someone sent anywhere. Not only that, you can also detect, so it's kind of a self-healing or self-learning process then. Let's say, I don't know, I put in here a wall, well then the signal reflection looks totally different. But with SLAM, we can automatically detect that and put updates live within seconds. Yep, this was it from my side. Thanks.
Thanks, Bernd. Really cool technology. Yeah, any questions? Okay.
Hi, thanks for the talk. I was just wondering, you mentioned the SLAM technology, which makes a lot of sense to me.
Yeah.
But if you think about various use cases like B2C versus B2B, could you see it work also for B2B use cases? Do you see people walk around enough in offices so that the building gets mapped quick enough, or is that not applicable there?
Yeah, sure. I mean, if we look at this, this was one guy walking through the store for 1 hour, and that was it. So if you think about an office building, there are more than one guys probably who walk through the building anyways. So you don't have to have like 10,000 people walk through it. You have to have 1 or 2.
Yeah, sure, but then you would have to give the people a kind of a working order, walk around and.
No. You don't have to give. You don't have to give it to them. They just have to have like a small piece of code on their phone, a small technology running on their phone in the background, and it harvests the data, sends it to the cloud, and the cloud does then actually the smart stuff. Did I answer your question? Damn it. But maybe I don't understand it. Okay.
Just maybe I have one question. I guess you heard about Project Tango from Google.
Yeah.
Is your technology significantly different to what Google provides?
From what I understand is that Project Tango actually more aims for the visual aspect of it, to create visual maps, to create to create the visual maps and not so then to create on the positioning data.
Okay, but would it be possible also with your technology create some kind of pseudo indoor maps out of this one?
Yes, and we actually do. We actually do. So we do not only create the fingerprints, we also create visual maps. I mean, they're not 100% correct, because maybe it's 10 meters and not 15 meters, and because of the sensors drifting, you then have 50 meters. But in the end, you see it in the building plan, and it looks quite nice actually.
Yeah, exactly. I mean, that was also my thinking. Yeah.
Okay.
Cool. Oh, man. Oh, another question.
My question is about the crowdsourcing aspect too. Would the data be open, or what should be, or would be the incentive for people to install your app?
Actually, we don't create apps, so we give the SDK to various people, and there are big companies or corporations who want to, let's say, I'm in Spain and I'm a Spain telco operator and they want to provide positioning all over Spain, and what they do is they take our, I'm just saying Spain because I don't want to say the other country. What they then do is they plug our SDK into one of their applications actually. Like all telco provider have an application where you can check which data plan you're on and how many minutes you got left and so on. And this application then does the crowdsourcing for them. What's about privacy?
Again, for the
Yeah.
are the people informed that there is something harvesting the data of their position in the background, or is it
As
you have
we
to
all
read
know,
the-
no one reads TNCs.
Okay, so you don't have a problem because it's of
For
course
us,
a-
for us not, because we
Okay.
just provide the technology. Was what the people then do with it. It's the same as Swisscom did a quite clever thing. I think it was 2 or 3 years ago, where they want to know how the signal mapping of all their cell towers actually looks like. And what they did is, inside of one of the applications, they installed a small sniffer that woke up, looked how the cell data looked like, and sent it back to the servers. Normally, it takes them around 2 to 3 months of 5 teams driving around whole Switzerland, mapping out that data. But so they had it instantly within 2 hours. People do that nowadays. Just also I don't know which telco operator you're using, but they are reselling your data as well, anonymously, obviously, of course. But this is when you sign your mobile contract, you're part of it. Every one of us. You just don't talk about it.
Okay, you happy now?
No, but
Okay.
I totally understand your point. But it is already in the process. It is already, people already do that. Facebook also harvests your data. Gmail as well. It is, I think, from my perspective, data privacy is not existing anymore. As soon as you communicate via email, all your data everyone has. Even if you have an encrypted server, you send it to someone who's using Google Apps, for instance, then they read your email as well, and they have their email. So data privacy is, but that's a totally different.
Yeah, I think it's it could be end up in a very longer talk.
Yeah.
Maybe a final question? Yeah, okay.
Hi Bernd, can you just explain the color coding and the visualization?
Yeah.
And also, it's not clear to me if the participant here has just walked at random through this space, or if they've purposely tried to walk to actively map every space here.
So the color coding blue means that the quality of the fingerprint compared to the other fingerprints around it is correct and looks good, and the fingerprint is a fingerprint you can work with. I can put you in contact with one of our data analysts who can explain it to you in more detail. I'm not that scientific. And how they work, how he actually walked through the building was just path. He just went randomly through the whole building for an hour, and that was it.
Thanks.
Thanks. Okay, then I think we close the session. Thanks again, Bernd.
Yep, thanks.
I think we have another coffee break. I would say the next presenters are those ones. If I just get it running, wherever. So if you could bring your presentation here, that would be nice. And